All right, so let's see what we have up in here. So my suggestion is you wander along with this video and feel free to do the problem as we go. Feel free to pause whenever you want and think ahead and try to process. I'm going to try to help you with that processing, but if you can do the processing, then that's even better. So my first goal is to figure out, okay, from the stem of the question, which is just the kind of basic information without any actual ABCD questions, what can I figure out? So that's what I'm going to do here. Again, feel free to take a moment and process that yourself, but I'm going to go ahead and get it going. Rate of fuel consumption, that's in gallons per minute, is given by the twice differentiable function. So we can take two derivatives. So two derivatives and strictly increasing. So for strictly increasing function r, that means r prime is greater than 0 always. And we have our table of r values, and they gave us a graph. That was very kind of them. So let's see what we have. So we know we have a rate. So we are given a rate. So if I were to integrate r of t dt, that's in gallons per minute. I don't want to say equals. That's in gallons per minute. So if I integrate that, that would be gallons. And more specifically, that would be how many gallons are used over whatever time period I'm integrating. If I take the derivative of that, that's the rate of the rate. So that's the rate at which the rate changes. So that would be in gallons per minute squared. And I know I can take two derivatives of that. We'll figure out if that's got to be useful somewhere. We'll figure out where. And then we know we have table of values, so we'll probably have to do a Riemann sum. We could do a left or right and a trapezoidal, obviously, but we could not do a midpoint. We don't have equal intervals, so we can't do a midpoint. And then we're strictly increasing, so that's got to be important somewhere. That's going to probably have to do with whether we're an over and under estimate. If we're strictly increasing, that will tell us, depending on which sum we're talking about, whether we have to be an over or under. If I draw on this picture, if we take left sum from those points, then that's obviously going to be under, and if I took a right sum, that's obviously going to be over. I'm not making a beautiful picture, but I'm just trying to process what's going on. So as soon as you read a question, you should start pondering, okay, how is this useful? What do I do? What can I use? And so I've done some of that. Now let's look at the first question. Now the first question says, use the data from the table to find an approximation for r prime of 45. That's just slope. So if I want to approximate an instant slope, I can use a average slope. So that's channeling kind of my inner algebra 1, more basic concepts. I'm going to focus in on right here. 45 is between 40 and 50. So I'm going to do r of 50 minus r of 40 over 50 minus 40. That's going to be, let's plug the numbers in, 55 minus 40 over 50 minus 40. Oops, it looks like I crossed that out, so let's undo that. 50 minus 40. Now, if this is the AP exam, just leave it like that. And we need to put some units on there probably. So that's going to be in gallons per minute, so per minute squared I could put. If that's the AP exam, you can leave it like that. That's totally fine. If you want to simplify it, you could write it as 15 over 10. If you want to get even spicier, you could take a 5 out of each one, call it 3 halves. I prefer fractions, so feel free to roll with that. So that's gallons per minute squared. Now that's the rate at which the rate is changing. The rate at which the rate is changing. If I think of that in physics terms, which for some of my students is helpful, that's like acceleration, where I'm looking at velocity here, and that's like acceleration. But that's not necessarily the best thing to do, because then you'll be thinking of a physics context, and you don't want to think of a physics context when we're not at all in physics land. So be careful. All right, for part B, let's see. The rate of fuel consumption is increasing fastest at t equals 45 minutes. What is the value of r double prime? So that means that the rate of fuel consumption is r. So that means r is increasing fastest at t equals 45. So let's break that down. If r is increasing fastest, that means r prime is has a max. Because r prime tells me about increasing, decreasing of r. So if r is increasing, r prime is positive. If this is the fastest that r is increasing, that means that r prime is the biggest it could be. Here's where the twice differentiable part comes in. That means I can then talk about r double prime. Since r double prime has to exist because r is twice differentiable, r double prime must equal 0. Here's my justification. R double prime equals, not always, R double prime at 45 equals 0 because since R is increasing fastest and R is twice differentiable, R prime of 45 has a max, and R double prime of 45 must be 0. I think that will cover it. I think we'll do okay. What is part C? Approximate the value of 0 to 90 r of t dt using a left Riemann sum indicated by the data in the table. So I'm going to first draw my picture because I know for some of my students that's going to help. So a left Riemann sum, 0 to 90, 5 subintervals. So 1, 2, do a little better than I did on the front page, 3, 4, 5. Now be careful. Notice the subintervals are not the same size. So if that picture helps, awesome. If it doesn't, if you don't want that, that's totally fine. You want to go 0 to 90 r of t dt. And then it's an approximation, so I'm going to make an approximation symbol. On the AP exam, they are not going to quibble one way or the other too much about an equal sign versus an approximately equal sign because they don't want to mark you off for not having an approximation, but you actually did because your handwriting's just a little wonky or whatever's going on. So approximately, that first subinterval is 30 wide by 20 tall. That second subinterval is 10 wide by 30 tall. Next one is 10 wide by 40 tall. And that's 10. And then next is 20 wide by, 55 tall. And the final one is 20 wide by 65. Now you could do this calculation. You don't have to. I'm going to put some units on there. Those are in gallons. If this is in class, sure, add all those up, get the number. Sounds great. If this is on the AP exam, don't. Write it like that. You're done. You're good. Now, if you're confused, let's recap. My first interval was 30 by 20. That took care of that. Check. My second interval was 10 by 30. That took care of that. Check. Then 10 by 40. And then 20 by 55. And 20 by 65. Now suppose you don't want the picture. That's okay. Look here. Let's see. If I want to go 30 times 20, because that's the difference here is 30, and then 10 times 30, 10 times 40, 20 times 55, 20 times 90. Try again, 20 times 65. So those would be your sums. You can look at the table also. That's if you're doing a left Riemann sum. Obviously, if you're doing a right Riemann sum, we'd go the other way. 30 times 30, 10 times 40, 10 times 55, 20 times 65, 20 times 70. And if you're doing a trapezoidal, just add those two together and divide by 2. Now I have not finished this question, so let's finish. Is this numerical approximation less than the value of the integral? My argument's going to be this approximation is less than the integral, 0 to 90 r of t dt, because r is increasing. So left Riemann sums are going to be underestimates if a function is increasing. Part D, last part. Let's see what we have. Still have the same stem. Fuel consumption rate, gallons per minute, twice differentiable. And 0 to 90, explain the meaning of 0 to b in terms of fuel consumption for the plane. So the integral 0 to b r of t dt, as I alluded to earlier, is the amount of fuel in gallons used by the plane or consumed by the plane in b minutes. And then integral 0 to b r of t dt over b, notice how I rewrote it because it makes more sense in my brain, is the average value of the function, and the function is the rate of fuel consumption. So it's the average rate of fuel consumption of the plane in gallons. Let's see, integral is in gallons. So then I divide by b, which is in hours, minutes. Gallons per minute in b minutes, or from 0 to b. Average rate of fuel consumption of the plane in gallons per minute. So I explained the meaning, and then I indicated units of measure. So I did both pieces as requested. Let's recap the whole question overall. We are given a rate. Keep in mind that is a rate. It's very important to identify what we are given, and we're given a rate here. Since we're given the rate in gallons per minute, we are twice differentiable. We are strictly increasing. The graph of r is given and the table is given. Okay. Now we want to find r prime of 45. R prime of 45, once again, is an instantaneous rate, but since we have the data in the table, we use an average rate of change to find what that was. So we found the slope between those two data points using our Algebra 1 work that we have previously learned. Part B, the rate of fuel consumption is increasing fastest at t equals 45. So that one's confusing. R is the rate of fuel consumption. It's increasing fastest, so that means it has the max amount of increasing. So that means increasing is the biggest number there. The derivative of r is r prime. That tells me when the function is increasing or decreasing. Since r is increasing, r prime is positive. R prime is most positive at t equals 45. That means we have a max on r prime. If we have a max on r prime and we have a second derivative, which we know we have from the twice differentiable piece, then r double prime has to be 0. Now the way you can look at this, which I didn't mention before, is check out this curve. See how we're going concave up? And then at 45, we go concave down. Right there is a point of inflection. Well, what's going on the second derivative when we talk about a point of inflection? If you don't know that, that's where the second derivative is changing sign. If the second derivative exists, then the second derivative is also 0 there. Approximate the value of 0 to 90 using a left Riemann sum. So, I mean, fortunately, they gave me the picture, so I could just draw the rectangles. Keep in mind, on the AP exam, they do not look at pictures as justification. You have to show that calculation I showed. We determined that numerical approximation was less than the value of the integral because the function r is increasing always. Part D, we're just trying to talk about what these things mean. So the integral 0 to b is how much fuel the plane used in b minutes. And then the integral from 0 to b over b is the average rate of fuel consumption in gallons per minute over the time interval of b minutes. Let's look at our rubric. So we did part A. We found the slope. R double prime equals 45 since R prime has a maximum. Here, remember this is an older question, so now we would need to provide a little bit more justification. We need to talk about differentiability. And twice differentiability, sorry. And that's what enables us to determine the R double prime is 45. Part C, make sure you show those calculations. You need those widths and heights. Pictures are not good enough. Approximation left because the graph of R is increasing. You could just say R is increasing, not the graph of R. And then part D, I think I've said several times, so we are good to go.